So assalamu alaikum, this is our third part, and in this we will cover the types of magnets. So let's see one by one. So natural magnets. Natural magnets known as lodestones, which is a type of iron ore with magnetic properties. As in the history of magnet, we studied that a person, he find a stone that was attracting another stones or iron toward itself. So that was the pure or natural magnet stone. So any type of stone that is attracting or repelling other stones or other iron or materials, they are called the natural magnets. What are the artificial magnets? Materials in which magnetic properties are produced artificially, such as iron, cobalt, nickel, steel, and in labs mostly we are using artificial magnets, and they can be in different types. It can be in horseshoe magnet, it can be type of bar magnet. A bar magnet has south pole and north pole indicated on that. Magnetic needles, they are mostly used in compasses. Disc magnets to attach something. Ring magnets for revolving or rotating anything, we use this type of so these are the all types of magnets that are artificially made for any specific application. Temporary magnets. Temporary magnets are those which lose their magnetic properties easily or after some time or after ending some specific process. If we attach some nail, steel nail with the battery, so one end of the nail, the positive, you can say the positive side of the battery attached with the nail, that will be as a south pole and negative as a north pole. So the nail will remain or act as a magnet till it is connected with the battery. Once we remove it from the battery, it will slowly start losing the magnetic properties. As soon as we will remove the battery, the nail will no more act as a magnet or north or south pole. So this type of magnet are called the temporary magnets. Permanent magnets, which retain their properties more longer and difficult to magnetize, especially steel. Permanent, there is a difference between permanent magnet and natural magnets. Natural magnets are those stones or lodestones which will never lose their magnetic properties. But permanent magnets are those which can lose their magnetic properties, but it's very difficult and after a long time, not as soon as early as temporary magnets. So permanent magnets are which retain their properties more longer and difficult to magnetize. Electromagnets. Electromagnets, an electric current produce magnetic effects, and a coil of wire carrying a current acting as an electromagnet. Like electric fields, electromagnetic effects are formed in electrical components or devices, and that is called the electromagnets. How electromagnet works? It will be a coil and a wire will be rolled on that, and it is acting as an electromagnet. In the picture you can see the example of a doorbell in which electromagnets are used. So what are magnetic fields? Last time we studied about the electric fields that were from the positive to negative, and they were close if the strong field is there. Same, almost same, a bit different properties are in magnetic fields. So magnetic field is the area around magnet in which magnetic forces are apparent. So in electric field, what was happening when the electric current was flowing through it, so it was forming the electric field. But in magnetic, because magnet is itself a lodestone or a component, so there is always a magnetic field around a, a magnet. What are those properties of that magnetic field? Travel away from north and towards the south pole. What was in electric field? It was from positive to negative. So in magnetic fields, the fields always originate, or you can say start or move away from the north towards the south pole. Second is magnetic field lines are close continuous curves. Same, no two lines intersect with each other, same as electric field lines. Tend to repel each other, helps distribution of magnetic field, because they are all moving towards the south pole, so they will obviously repel each other, because the same pole repel and opposite attract each other. Travel more easily through magnetic stable materials than others. Same. So all the rules we study of magnetic field, they were also same in the electric field. Only difference was north pole and south pole, and there we use positive and negative in electric field. So what is magnetic induction? Production of magnetic properties in an object by magnet without contact is called magnetic induction. To understand this, look at the picture here. A magnet having south and north pole, and the first nail is, this nail is attached to the magnet. This nail is attached with the magnet. Now what it is saying, production of magnetic properties in an object by magnet without contact. Magnet is in contact with this nail, but magnet is not in contact with the second nail. Why the second nail is still attached with the first nail? Because the magnetic properties of an object of the nail is changed by this magnet. So that's why it also become the magnet, and it's attracting another nail, and this nail is also attracting the third nail. So here the property of the nail is changing due to the magnet, and that is called the magnet induction. So let's read this. Demonstrated by using a magnet to pick up some paper clips or iron tars, because one paper clip will attach with the magnet, and that magnet will change the properties of the paper pen. The paper pen in contact with the magnet attracts another paper pen due to the fact that it also become magnetized. This second clip is also magnetized, and so on. Opposite polarity develop at adjacent end and same polarity at far end, as unlike pole attract each other and repel each other. So the ending point of one nail, you can say, is one pole, and the joining point of another nail is separate or opposite pole, because they are attracting to each other. So in today's lecture we have covered what is magnet. It is a simple material which produces magnetic field. And what are ferromagnets, which are attracted towards the magnet. How magnet works, because there is a nucleus inside it, electrons are revolving around it, and this type of motion is create the magnetic field, and that is how magnet work. History, it is 600 BC old. Greek word was used magnet. And why magnet used? Because the person who found the first stone was Magnus, so on the name of that it was named as magnet. First device was compass. Applications are in everyday life. In all the electrical and electronic devices, magnets are used. Types of magnet materials, we these are type of alnico because it is made of aluminium, nickel, cobalt, and mostly used in our labs. This type of mostly used in our appliances, in our medical applications. High energy fraction mostly used for outdoor applications. These for sticking because they are small in size and have high magnetic power. These are mostly used to make the permanent magnets. Natural magnets are which will never lose their properties. Artificial are which are made with for different applications. Temporary which are made for specific time. As far as we will remove the source of power, it will lose its property. Permanent which for which it is not easy to lose their property, but one day it can be weak, but it can't be like a natural magnet. Electromagnets are formed with a coil or by making electromagnetic effect by passing electric current through the coils. Electric fields and magnetic field properties are almost the same. The only difference is in electric field we use positive and negative, in magnetic we use south and north poles. And magnetic induction is the procedure when a magnet change the property of an object by contacting in with them, and then that object will attract other objects, and that is called the magnetic induction. So thank you for today's lecture.